Welcome to clickmyproject.com. Our product entitle is on the design of mutually aware optimal pricing and load balancing strategies for grid computing systems. Next we move to abstract. Actually, in this product based on the design of mutually aware optimal pricing and load balancing strategies for grid computing systems. It managing the resource and cleverly pricing the amount computing system is a challenging task. Resource sharing demands careful load balancing and often strives to achieve a win-win situations between a resource providers and users. Towards this goals, we consider a joint treatment of load balancing and pricing. We do not assume the static pricing to determine the load balancing or vice versa. Instead, we study the relationship between the price that computing and nodes is charged and the load and revenue that is the resource. We find there existing an optimal price which maximizes the revenue. We then consider multi-user environment and explore how the load from the user can be balanced on processes with the existing loads. Finally, we derive an optimal price that maximizes the revenue in the multi-user environment. We evaluate the performance of the proposed algorithm through the simulation. The main aim of this process is pricing, load balancing, cost, revenue, and response time. Next, we move to workflow about the project. Start the process. Create the users and load balancing approach to minimize the job response time and cost in distributed system or grids have been developed in queuing models. By modeling each node as an queuing system, the expected response time at each node can be determined. Consequently, the optimal load distribution to minimize the overall response time for users' jobs is derived from the rate. We probably define this approach as a minimum rate. Using this approach and assume the constraint in a particular execution time to amount of response required in an optimal load distribution to minimize the overall cost for users' job is derived. We probably define the approach in minimum cost. Both approaches assume the price of all nodes are given that fixed and end the process. Next we move to execution process. This is an interior screen. That's home screen emitted on the design of mutually aware and optimal pricing and load balancing strategy for grid computing. Let's start the execution process here. So the execution process started from here. Create the single user. So it's the input of enter number of users. I enter 12, click OK. Enter user successfully created. Okay. And enter the multi-users here. And do the multi-users here. Create the multi-users for this here. It's a multi-user process. Every user creation user and multi-users and multi-user environment. Created in the multi-user this program. To managing the resource and cleverly pricing them on computing systems is a challenging task. Next motor and data configuration. Yes, constant local development. Create the managing resource and cleverly pricing them on computing systems to make the task. Data analyzing. So on this actual analyzing data is created and providers as analyzing results completed. Next move to next screen. This is a single user. System data. Two data is created successfully. Let's create the broker. Brokers created in this center. Create the brokers. So brokers created in brokers and brokers already created in this windows. Next we move to next screen. So start the main process of this and installations and contributions development and create the databases in a data and broker communication. So first at data creation. So data creator created the data studio. 12 data centers are created here, and 12 data was created successfully in data center, and create the data and data start created process, and is completed a data process completed, and start the broker creator process started, and get brokers 12 brokers and 12 created successfully, and the data center broker and data broker ID determine this process and complete the data process completed, and move to next screen. Virtual machine creation. Create a number of virtual machine in this process. Virtual machines created and virtual machine submitted to respective broker successfully, and created particular selectless process and later grid-led, and in this grid-led we create the virtual machines and virtual machine constitutions. To create the virtual machines we have to enter the success. If database is successfully created, the process will successfully created here. So enter the virtual machines to create the successful answers. Move to next. Will submitted to respective broker successfully. Move to next. So load constructions is optimal load balancing integrated over optimal load balancing is created here, and is created to the virtual ID, and this grabs the load constructions a particular data set, and improve data process and system host load, and this optimal load balancing is load balancing. So optimal is minimum cost calculated on the entire process, and minimum rate connected with this process. Move to next. So monotonically increasing and monotonically decreasing. It's an indicator optimal pricing. So indicator optimal pricing in these computing systems. First to create the optimal pricing virtual machine. So it's a virtual machine ID and load pricing, and clear the process. And host load pricing. In this host load pricing, host ID and load pricing. Clear this process. Pre-assigned rates. The pre-assigned response rates created successfully. And pricing solution with pre-assigned rates. So pre-assigned rates created successfully. Complete the every process the integrated optimal pricing in monotonically increasing and monotonically decreasing. So next we move to exponential distributed variable rates. It's like to moderate loads and moderate to heavy loads. And this containers and create the manage the process. We create the process as the minimum cost and rates. The minimum rate and minimum cost in global it's created successfully. So clear the first process. Next pricing with load balancing. So create a pricing with load balancing and optimal pricing global. Pricing with load balancing is clear. And moderate to heavy load. Minimum cost and rates. Calculate the minimum rate global and minimum cost. Clear this process. Again, the pricing with load balancing. This pricing with load balancing is optimal A and optimal B. Clear this process. Next, we find the every light to moderate to load. It calculated successfully, and moderate to heavy load calculated unsuccessfully. Moderate to heavy load in minimum cost range connected to this range, and moderate pricing with load balancing calculated this way. Next, we move to good job distribution. The job allocation process, cost machine, time, and waiting time, and allocation. The job allocation time. This process executed here. The task, a virtual machine, the response time, and processes to the next